Welcome to the direct instruction for Sunday, July 2nd, 2017. And here's some topics we're going to touch upon. These aren't in any particular order. I just went through and identified the various ones I wanted to talk about, the technology behind it, and also maybe a little bit by hand. The videos I put out there, instructor YouTube supplemental videos, these will include information about how to do it by hand, so I'm not going to focus a lot on that. There's also some calculator usage out there, but I'm going to show Excel. Okay, well, first thing, let's introduce Excel. And this may be boring to you. I don't know how much Excel you've had, but of course this is a sheet here. And you see a sheet 1, sheet 2, sheet 3. You can click between these to go between different ones. You can click here to put a new worksheet in, like that. You can double click the name. Like if I double click sheet 4 here, I can then name this sales or whatever I want to call it. I'll go back to sheet 1 though. I made this larger so you can see it. To type in numbers, just simply type them in and press enter. Okay, so we got some numbers here. To change numbers, you just click the one you want to change and retype it. To press delete on a number, like if I press delete on 23, deletes that number. If you want to right click on it, by the way, Control Z undoes everything, and that's also up here. I see the undo typing, and there's also a redo right here. So if I delete this, I could remember Control Z, but also could click this undo up here. Now if I right click the cell, I can choose delete, and this will cause the cells to shift up, which is kind of handy. If you really want to get rid of that completely, but you want all the numbers shifted up, then that's how you do it. And again, I'll do an undo there, put it back. You can do a row. If I click over here on the 1, for example, and I right click on it, and I choose delete, it'll delete that entire row. I'll do undo. You could undo the column. If I click on the A and right click on it, I can choose delete, and it'll delete that column. And again, undo. Okay, so that's just some basic data entry. To begin with, you want to go to File, and you'll see options in some form down here. You might have a different version of Excel, so it might be slightly different, but you'll see options. Now when this comes up, you may have this look slightly different, but we're looking for the one that says add-ins. And if I click that, then you'll have maybe some different information here, probably not same as me. But at some point you'll see manage somewhere on the screen. And you see it says manage Excel add-ins. If I do the drop down, you can see there's other items, but Excel add-ins is what we want. So I click the go. And you want to select Analysis Toolpack, Analysis Toolpack VBA. So you have to have those chose. Now once you mark these, like yours will look like this to begin with. You just come in, click these to check them. Then you click OK, and that adds that toolpack in. Now under the Data tab, you'll see a Data Analysis, and we'll get into that more. Okay. Let's skip down to the mean, and we'll talk about that first. Well, mean is another name for average. Excuse me. Let me grab a drink here. And if I had numbers, so I had 3, 8, and that's 11 and 1. To find the average, Now, the book will talk about the difference between sample and population, but X bar that you see right here, this is referred to as our sample mean. And a U with an extra line on it, that's our population mean. Like I say, the book will talk more about or the ebook will talk more about what is a sample versus population. This is mu. It's a Greek letter. So mu is our population mean, X bar is our sample mean. I had one student told me one semester they had a really hard time with statistics until they memorized these symbols I'm going to be giving you here today. Once they memorized these, then whenever they ran across them throughout the course, they knew immediately what it was. Okay. Now, our formula for a sample mean is going to be the sum of the x values divided by n. Now, this E-looking character here, this is uppercase sigma. That means add together your x values. Well, 3 plus 8 is 11, plus 1 is 12. You'll see n throughout this course too. N is your sample size. So n is your sample size. There's also uppercase N, which is your population size. Well, we got three numbers here, so our n will be 3. And then 12 divided by 3 is 4. So that would be our sample mean. Okay, now if I have this item right here, or this set of data and I want to find a mean of it, I can do an equals, and a lot of the functions you can just start typing it and you'll see it pop up. But if you type mean, you won't see anything there. Now you do have to have the equals there, but if I start typing average, you'll notice that average is there. So the word mean is not used in Excel, it's average. Now I'll do my beginning parentheses. In Excel, it's very picky. You have to have it exactly like I'm showing it here. We do our beginning value, which is A1, colon, and then our ending value, which is A8, and then closing parentheses. You'll get used to that referencing, but that's your range of data. So it's going from A1 to A8. Now if I press enter, it gives me my 61.25. Now let's say I don't remember the function. If I do an equals, and I start thinking, okay, well, what should this be? Well, there's a fx up here, it says insert function. And if you choose that, then you can do this drop down, and you can choose statistical, or you can choose all. Sometimes it'll be under statistical, especially for the ones we're looking at. And if you don't see it, then you choose all. This is every function that's available on Excel. Okay, so I'll go back to statistical, and you see there's average here. Tells me a little bit about, returns the average of the arguments. It can be numbers or names, arrays, references, contain numbers. You click OK, and it'll pop up with a halfway user-friendly screen to fill out. And then you can see that says C2 to C3. You could type in A1 through A8. That's what I'd recommend if you're just learning Excel. You can also click this little button over here, and then you can click with your left mouse button, hold down, and drag down to the bottom, and it'll put A1 to A8 in there for you. And then you click this button to go back, like that. You can also, instead of clicking this button, just click right over here and drag and drop. And it'll automatically put it in there. So different ways you can fill that in. And then you click OK. Okay, I'm going to press delete to clear that out. Now there's data analysis here. If I choose data analysis, you see there's descriptive statistics. So if I choose that and click OK, input range, well, I got an A1 colon A8 again. And you see there's a summary statistics down here. So if I choose summary statistics, New worksheet is fine. And click OK. Then you can see that it calculates a whole variety of items for you. One of them being the mean. So different ways you can get the mean. Okay, I'll just mark these off as we go through them. The median. I don't know if median's over here or not, is it? Yes, it is. Median's here, so you can do it with the descriptive statistics under data analysis. That's one way. You can also equals, and you start typing median. It'll tell you if there's a function there, and if I just do a tab to finish that out, it'll put median and then beginning parentheses, A1 colon to A8, and that'll tell me my median is 59, which matches that right there. Like I say, I'm not going to show how to do that by hand. The videos I put out there show how to do it by hand. Sample standard deviation. Now I'm going to show how to do this with technology, then I'm going to back up and I'm going to do it one by hand. Because it's important that you know how to do sample standard deviation by hand. Okay, do an equals standard deviation. And there's different ones here. You see there's standard deviation.p and there's standard deviation.s. And this this says calculate standard deviation based on an entire population. And this one says estimates standard deviation based on a sample. So if you're finding sample standard deviation, you want to use this standard deviation.s. And then I'll put in A1 to A8 and press enter. That gives us 31.26, and this is our sample standard deviation. This is our median. This is our mean. Now I can do population. So if I do equals std, here's the stdv.p. And again, it has to match this exactly. You can't have a missing parentheses. You can't have like that missing beginning parentheses. And then press enter. And you see we get a different value. And that's our population standard deviation. Over here, here's our standard deviation, 31.267. And you see it's put in the sample standard deviation. It doesn't say it over here. It just simply says standard deviation. Most of the times, what you're finding is your sample standard deviation. There's not a whole lot of need for a lot of in-depth statistics if you got your entire database. If you already know what the population is, like you know the exact standard deviation of all the ages of everybody in the United States, you have access to the entire database, and then it's just a matter of compiling reports. So sample is mainly what we're concerned with. Okay. And population is 29.2479, so forth. If you look over here, you do not even see population standard deviation descriptive statistics over here. So that kind of gives you an idea of what's more important. Before we leave this topic, if we talk about sample variance, and I really don't know if there's a function for this, I'll have to look myself. The sample variance is the sample standard deviation squared. So I can do an equals and put C6, because that's where we had our sample standard deviation, and then the caret, which is above your 6, so I'm doing shift 6, and then 2, and then push enter. Now let me see if there's a function. Equals variance, I guess there is. Variance.p for population, variance.s for the sample. And then I do A1 to A8. Again, all of your functions have to start with equals. And that gives us the same value, which it should. Now our population variance. The reason why I don't use the functions a lot is because it's just as easy to square the population standard deviation. So I do an equals C7. That's our population standard deviation. Shift 6 for the caret, 2 for the second power. Okay. Now if I come over here, this one actually says sample variance 977, so you can also get it that way. Let me go back here and we're going to work a problem where we find the sample standard deviation. There's different formulas that you'll find. I'm going to show you a very basic formula. All of them give you the same value in case you're curious. Our x values always represent our numbers. So let's say 1, 5, 20, and what's that add up to? 26, so another 6, 26, 31, 32. That'll work. Our formula for sample standard deviation is S is equal to the square root of the sum of x minus x bar squared divided by n minus 1. Well, this x bar right here tells us that we need to find our sample mean. So remember, our sample mean was equal to the sum of the x's divided by n. So if I add these together, this is the sum of the x's. 26, 31, 32, so it adds up to 32. So I'm going to have 32 divided by n, and I have 4 numbers, so n is 4. And that gives us x bar is equal to 8. Now, we have x minus x bar, so I'm going to create a new column where I do x minus x bar. So I'm going to take each x value minus the x bar, which is 8. And that gives us negative 7. We got 5 minus 8, which is negative 3. 20 minus 8, which is 12. 6 minus 8, which is negative 2. Now that's our first column we're working with. Now we need x minus x bar squared. So we're going to take these values we just found, we're going to square them. So I got negative 7 squared, which is 49. I got negative 3 squared, which is 9. I got 12 squared, which I believe is 144. And I got negative 2 squared, which gives us a positive 4. Now this uppercase sigma is in front of here. This tells us that we want to sum those, add them together. Now if you've worked with Excel at all, you probably have seen that symbol. That's what that means in Excel. It means to add, sum. Over here, under the Home tab, if I want to add together these numbers right here, then you see there's an auto sum up here. That's that little E-looking symbol, uppercase sigma. And if I click that, it just puts a function there, equals sum A1 to A8. And then you could do this check mark to choose it. So that adds up all these numbers. Okay, let's see. 8, let's see, that's 18, 22, 26. Carry the 2. 6, 10, 206. Let me double check that. Let's see, 193, 197, 206. Okay, that looks right. So now we're ready to plug everything in our formula. The sum of x minus x bar squared is 206. Over n minus 1, we said we got 4 numbers, so 4 minus 1. So we got s is equal to the square root of 206 over 3. And if I plug that in, actually let me just do it over here in Excel real quick. Square root of 206 divided by 3 gives us 8.29. And that'd be our sample standard deviation. Now, definitely, you can check that. Now, if I go to sheet 2 here, make this a little bit bigger. I'm dealing with 1, 5, 20, and 6. Come over here, I do equals standard deviation of a sample, A1 to A4, 8.29, is that what I came up with? 8.29, so that checks. Now some notation. S is our sample standard deviation. S squared is our sample variance. If I had a problem as asking me what the sample variance is, I would want to square this value right here. Now, I would not actually want to square 8.29 because that's the rounded off version. I would want to square all of this. So if I do equals C3 caret 2, that's that squared. Compare that versus 8.29. Sometimes there's not much difference. If I do equals D3 squared, and you see we get 68.67, and here we get 68.72. Very important statistics. You never use a rounded off version in the middle of a problem. Always at the end is where you do your final rounding. Now, a little O-looking symbol like this with an extra flip. This is our population. So maybe I can spell population. Standard deviation. That symbol is lowercase sigma. You might say, well, you said this was sigma up here. Yeah, it is. That's uppercase sigma. This is lowercase sigma. Sigma squared is going to be our population variance. Again, these symbols I'm giving you here are the ones you should know or have real handy as you go through this class, through your readings. It'll help you to understand what these are used for. Okay. That was our sample standard deviation, sample variance, population standard deviation, population variance. Now quartiles. Let's talk about those. Go back to here. And we got quartiles. We got our first quartile. We're going to have our second quartile, and our third. There is no fourth quartile. So I do an equals, and if I start typing quartile, you see there's these top two. This bottom one, even though it's just available for compatibility with Excel 2007, I think it's the easiest one. But if you choose that quartile, and then you do A1 colon A8, comma, and it pops up and tells you the first quartile, you have to put 1 in, right there. You put 2 in for the median, which is the second quartile. You put 3 in for the third quartile, and then the maximum value you get by doing that. Okay, but I want to put 1 in. And you see it says equals quartile A1 to A8, comma 1. That gives us our first quartile. Now the one that's equivalent to that in the formulas is that if you do an equals quartiles inclusive, the second one, and then you put in your A1 to A8, comma, you put 1 again for your first quartile, closing parentheses, so this is how your function view look. Again, you have to have that equals there. And press enter, you get the same value. That's kind of up to you. But I'm going to do the quartile here, A1 to A8, comma 2, for the second quartile or the median. And then equals quartile A1 to A8, 3, and then press enter. This would be our first quartile, second, third quartile. I don't think they're over here. No, I don't think they're over here. But that's how you can get your quartiles. Now Q3. Q3, or IQR, IQR is equal to Q3 minus Q1. I don't think there's any function for this. I never have looked for it. Let me see. Enter. No. Reason why is because it's just subtracting two numbers. So I do an equals, and then Q3, which is C13, minus, and then Q1, which would be C11. You'll notice a nice coloring that Excel does, so you know which is which you're dealing with. So you can visually look at it and see how you have your formula set up. And then push enter, and that gives us our IQR is 55. Grab another drink here. Our central air is broken in our house, so it's kind of warm. And I shut off the air conditioner so you could actually hear me. Okay, IQR. Now the rest of these start getting into the graphs. So let's go back here and look at a stem and leaf plot. Some of these are just by hand. You can't do them in Excel. Not easily. You can do them in Excel. Okay. Let's say I had 70, 71, 71, 72, 72, 72, 81, 83, 87, 89, 99, 103, and 105. Now, the last digit has to go on the right side here. So the 0, 1, 1, 2, 2, 2, 1, 3, 7, 9, 9, 3, 5. That will always go on the right side. The rest of it goes over here, but you don't repeat them. See how I have 7, 7, 7, 7, 7, 7? You put 1, 7. And then we'll start with this. We'll put 0, 1, 1. Put these all on one line. 2, 2, 2, so 3 2s. So it looks like that. Now for the 8s. Put 8, and then I got 1, 3, 7, 9. Like this. My next one's a 9. 99, so I'll put this digit on the right side. And then I got 10. And I got 3 and 5. This would be a stem and leaf plot. Now you have to kind of turn your head sideways to understand how to use this. This shows you the distribution of the grades. And if I kind of draw a picture around it, that right there, that helps me to see how my data is laid out. If I return my head sideways and more or less it looked like this would be symmetric. If I turned my head sideways and the line pretty much went straight across, that'd also be symmetric. So symmetric is both these cases. Symmetric would mean that each one of these has the same number that falls in each category. Now, if my data look like this right here, trying to draw that as much as I could. You know, if I were to kind of complete this, it looks like this. Oops, I went down too far there. Now here it looks like all the data is over on the left side. This would be skewed right. It's always opposite what you think. If you think the data is all on the left side, then it's skewed right. On the other hand, if I looked at my data and went like this, what it looks like all the data is over here on the right side. This would be skewed left. Why is that important? Well, if we're trying to understand how this data is arranged, if your data is skewed left or skewed right, then your median is your better measure to use versus the mean. So we would use a median if it's skewed. If it's symmetric, then I would use the mean. Now, we would use IQR if the data is skewed versus using the standard deviation. So since our data here is skewed, we would use the median and IQR to understand, to measure the center and how spread out our data is. Now we're going to see the same situation exists with a histogram. Okay, the histogram. Let me clear this off. I'm going to put those numbers into Excel. So let me highlight all this and delete it. 70, 71, 71, 72, 72, 72, 81, 83, 87, 89, 99, 103, 105. Now this is from A1 to A13, so keep that in mind. I choose my data tab up here, and I want to choose the data analysis. And you'll notice there was one called a histogram. So I click OK. It's asked me for my input range. And so I'll go from A1 colon to A13. You see there's a chart output. We want to have that selected. And leave all the rest blank. And click OK. And you see we got our data here. Now I shouldn't have erased this over here. But if I remember right, we said it was skewed right. And if you look at this, it looks like more of our data is over on the right side. So you're sitting, well, how in the world does that coincide with what we're seeing here? Well, it has to do with the bins. And that's what we're going to play with a little bit now. Here, when we did the stem and leaf, this first one's 7. So this included everything from 70 to 79. When we did an 8 here, this included everything from 80 to 89. Of course, it would take into account decimals also if we were to include that. To get Excel to do that, let me come over here, back to sheet 1 where I put my data. And I'm going to put my bins in column B. Now, your bins is your upper part of your interval. For example, the bins over here would be represented by 79, 89, so forth. So if I come over here, put 79, 89, 99, and 109. Excuse me. Choose data analysis. Gonna put it warm in here, so I'm it's kind of breathing a little bit. Okay, histogram. And my input range, I'll again type in A1 to A13. Oops, let's try it again. A1 to A13. Bin range, I'll put B1 to B4. Chart output still selected. So now if I click OK, Now we see a little bit better representation of our graph. This is would match our skewness that we indicated with the stem and leaf. It looks like all the data is over here on the left side, so it's skewed right. Now, much different than this right here. So if you're going to create a histogram in Excel, it's probably a good idea to use the bins, so you can control where do you want the data to go. Otherwise, Excel just guesses. It guesses where you want the numbers to fall. And sometimes that's good enough, but as you can see from here, this changed. Looks like it's skewed right here, and I'd say this is skewed left here. So I really, to be honest, I've never run across this before where it changes skewness like that. I suppose it's just how you put the numbers in and how it comes out like that. Now some other items while we're on this. I went back to sheet 1 where I have my data. If I choose data analysis, histogram, you can see it comes up with the output options. You can do the output range, new worksheets, what we'll always use. Pareto, that's where you have it sorted. Pareto probably doesn't make a whole lot of sense for this situation. Cumulative percentage, this is where if you're trying to look at as it builds up. But if I click OK, and I get to here, if I wanted to build the frequency distribution from this, and that's one of the things you're asked to do sometimes is to build a frequency distribution. Well, these, remember, your bins is your upper class. So those are upper class limits. So I got 79, 89, 99, and 109. And this was 6, 4, 1, 2. Those are our frequency. Usually what people want to see, though, is a range. And we've already indicated we want this to start at 70. So I can put a 70 here. So this first class here is 70 to 79, and there's 6 in there. Now, you notice when I did my bins, my upper class limits, I went by 10s. 79, 89, 99, 109. That's our class width. So this needs to go by 10s. So that's 70, 80, 90, and 100. You'll notice where this one stops, 79, then this one is the next number, which is 80. So there's not any missing data, assuming you don't have any decimals. If you have decimals, then you can handle the boundaries, or you can choose just different upper class limits. You could have 79.5, and then this might be 79.6, or whatever you might choose. That's entirely up to you or the problem we're working. Get back over to here, and that was our histogram. Okay, now weighted average. There's different variations of this. One of them, one type of problem, and I don't know what you might run across in the practice homework or anything, but one of them is where you have test scores, and then they tell you the final is weighted differently. The final is worth 2 test scores. And then they give you your tests. Maybe you got a 70, 80, 90, 60. And they want to know, what do you need to get on the final to pass the class? Well, you got your 70 plus 80 plus 90 plus 60, and then plus, and the final, since we don't know what the final is, that's x. But since it's for 2 test scores, we'll put x plus x there. Divided by 1, 2, 3, 4, 5, 6 total. And we're wondering what's it going to be required to get on the x in order to get a 70 in the class to pass, a C. So at this point, then you add all these together and you work it from there. So that's how you do the setup on that. Another type of weighted grade is where they tell you like tests are worth 20% and homework's worth 30% and so forth. And that's where you take your 20%. Let's say the test is worth 20%, and you multiply it times your average. of your tests. Homework, let's say it's worth 30%. That's where you take 30% times the average of your homeworks. There's different variations of this. It could be the percent. Like if you got 90% total on your homework points, you put 90% here, or 90. And then your final maybe is worth 70%. Let's try it again. 60. One more time. 50. Actually can add. And then here would be maybe what do you need to get on final to get whatever grade in the class. So these two multiply together, these two multiply together, these two multiply together, and if you add those, then that's going to give you some kind of score. So that's another way you can work a weighted average. The more popular one is the first one I showed you. And I guess we talked about frequency distributions. Now let's talk about bar graphs and circle graphs. Then we'll go back to the box and whisker plot. Now bar graphs and circle graphs, it's kind of a strange way to refer to category data. Maybe if I go through and count how many people have red hair. 20 people have red hair. Count how many people have blonde hair. 32. Black hair was 10. And what kind of hair color is there? Brunette. Brunette was 15. Okay. Now, if I want to come up with a bar graph that represents this, if I click with my left mouse button, drag and highlight all this, you can go over to Insert, and then there's a column here. And if I choose this first one, that's your very basic graph. And it gives you a bar graph representing the red, blonde, black, brunette, and so forth. Let me delete this. I'm going to click over here in this white area and press my delete key. Now, circle graph. If I do an insert, come over here to the pie and choose the first one. This will give us a pie graph showing the percentages. And there's different variations of this. You can choose different options up here, change how it looks. You can choose the layouts here, where you can put the percents there. So you see all the different options. You can use the drop down, and I guess there's just one more. Okay, so I'm going to delete that. Now, this is our frequency. If I want to do relative frequency, there's different ways you could go about that. I could instead put my frequency here. And here's where I'm going to put my relative frequency. Well, I need to add these together. So I do my auto sum, then do my check mark, and that's 77. So I do an equals here, and then I'm going to put in C1, which is a 20, divided by, and then I put in 77. And then press enter. Now if I click this cell here and put my mouse in the lower right hand corner, you see right now it's like a white plus sign. And if I put it there, it becomes just a real simple plus sign. If I click and hold down and drag that down, it'll fill this formula down for me into these different blanks. And you see, if I click on these, I'll see all of them are C2 divided by 77, C3 divided by 77, C4 divided by 77, and so forth. You could also put a times 100 in here if you wanted to. Now, it doesn't automatically change these. I have to fill it down again. So I click my first cell here, put my mouse in the lower right-hand corner so it becomes a regular plus, and click my left mouse button, hold down, and drag it. That takes a little bit of playing, but once you get that down, it's a very useful feature when working in Excel. So now I got these based upon percents. So now if I highlight this, and choose Insert and choose Column. Then you see a percents over here on the side. So very straightforward way to get that. Let me delete that. Okay. Now those were our bar graphs and our circle graphs. Now our box and whisker plot. If I have a set of data, let me put some data back in here. Let's see, 33, 60, maybe these are grades. 72, 75, 82, 85, 89, 95, 99, 100. Now we need to get the 5-number summary first. Your 5-number summary is based upon the min, Q1, Q2, which is also the median, Q3, and then the max. Now let's look at the formulas first. If I come over to D2 and I do equals min, beginning parentheses, A1 to A10, it gives us 33. And here I do equals quartile, A1 to A10, and I put 1 in. Here you could do a quartile again, or you could do median, A1 to A10, because remember median is same as Q2. And here if I do quartile, A1 to A10, and then I put in 3. And here I could do quartile again, choose max, or I could just simply use the max function, A1 to A10. Now that gives us our 5-number summary. 5-number summary is your min, Q1, your median, Q3, and your max. You could also, if I choose my data, choose data analysis, and choose descriptive statistics. Now I need to update it. Instead of A1 through A8, I want A1 through A10. And then do OK. You're going to see that our last numbers down here include minimum and maximum. They also give us a median. It does not give you Q1 and Q3. I think there is a way to do that. If you come here and I think it's rank and percentile. Of course, I guess I better go back to my sheet. I usually just use the formulas, but rank and percentile, and you put in A1 to A10. I think this gives it to you. Let's see. Labels in first row. Click OK. I'm probably lying to you. 85. Yeah, that doesn't give it to you. Okay, never mind that. Okay, but you got your 5 numbers here. To create a box, they call this a box and whisker plot. Some just call it a box plot. What you do is you look at your max. Max was 100. So over here I'm going to put 100. And then split this up accordingly. 50, 25, 75. And our min is 33. So I'm going to put where I think 33 is, more or less. What's halfway in between 25 and 50? I guess that'd be 37. So 33 maybe be about right here. That's our min. Our max is 100. Let's come over here. Draw one at 100. And then Q1 is 72.75. is Q1. Q2 is 83.5. And Q3 is 93.5. I'm kind of guesstimating where those are at. Then you draw a box around those, and you draw lines coming out like this. You can also draw it. I notice the book emphasizes theirs in this manner, where you put 100 up here, 50, and you have it with this orientation. That's up to you. Now the benefit here is if this also tells us how our data is arranged. You notice here it looks like all the data is over here on the right side. Well, that means this is skewed left. It's always opposite of what you think. That being skewed left, that would tell me I would want to use the median and IQR for the measure of the center and the spread. If my box plot came out like this right here, where all the data is on the left side, this would be skewed right. If my data came out, so it was pretty much in the middle, like this would be symmetric, in which case I'd want to use the mean and standard deviation for my measures of center and spread. But that's how you create a box and whisker plot. And there's a little bit more you can do to that. The book might discuss that, but that's a basic box and whisker plot we're looking at. Now, it looks like all of our topics I was going to cover, so I'm going to go over to the course briefly, talk about the arrangement of that, and then I'll stop the video and answer any questions you have. Okay, so for each unit, you'll have assigned readings and preparation activities. And so, for example, if I click this assigned readings here, this is the chapters you read out of the book. And there's some PowerPoints here too that you can go and look at. I have put some supplemental videos out here. These do not include the technology using Excel. So if you're looking for Excel, it's not under these. That'll be under the Collaborate sessions over here. Some additional resources. These are problems to do. Now these are, you see it says we will not receive a grade for this optional work, but I'd recommend you do this. And any of these you cannot figure out, you can email me. You can email me, say I cannot figure out how to create this graph, and what I'll do is I'll work it in a YouTube video and I'll send it back to you. Since this is not graded, the goal here is for you to master the material, and whatever way I can help, I'll help in that regard. Then down here you'll see there'll be discussions to do and with instructions. And also down here will be different assignments. Like here's one creating a stem and leaf plot. And we looked at how to do that already. And this you just probably need to put into a table in Word. Talk about it and so forth. Finding measures of central tendency. Well, that's what we already looked at. Remember mean and standard deviation and so forth. So there's an assignment on that. Now these assignments here I won't help you on. These are graded, so you have to do this as an individual effort on these. But if you don't know how to do something in one of these, go out here to the additional resources, the extra problems to do. Find a similar one. You can ask me about that. Like I say, I'll help you with any of these out here. I just won't help you in those assignments down below. And that's pretty much the overview of the class. If you've taken other courses, you know where syllabus is and all those different items. I just want to talk about it from a statistics standpoint. Don't feel like you'll bother me if you ask me any questions. That's why I'm here. I'll help in whatever way I can to help you understand the material. Try to simplify it a little bit. Statistics can be a challenge. So if you're sitting there feeling a little bit lost, you're probably not the only one. Be sure to ask. I like questions. I'll never make you feel bad about asking any questions. Now I'm going to go ahead and stop the video, and then I'll answer any questions you have.